Hello everybody. Today I want to talk to you about one of the best tools you have in trigonometry. It's going to be your best friend moving forward, and that's the unit circle. The unit circle gives us a convenient way to lay out our common angles, both in degrees and radians, and eventually we're going to also add some of our trig function values to it. To me, it's sort of analogous to our times tables. To try and do algebra without knowing your times tables, really tough. To try and do trig and calculus moving forward without knowing your unit circle, equally difficult. So please take a look. Right now we're just going to focus on filling out the degree angle measurements for our common angles on the unit circle. I'm going to begin by putting in what we call the quadrantal angles, the angles that appear on the x or y axes, and I think we're fairly familiar with these. So let me just add them in and we'll talk about how to get these other angles. 0 degrees, 90 degrees, 180 degrees, and 270 degrees. If you go all the way around the circle, this 0 becomes a 360 degrees. Right, one full lap around the circle is 360 degrees. Okay, so if you notice, we've got a bunch of angles already drawn on this circle, and often I'll refer to these as slices. I like to think of this as pizza slices almost. And the nice thing about the unit circle is you really just need to focus on quadrant 1. If you know the angles for quadrant 1 and how to deal with what we would call our anchor points, you can then go ahead and find all the angles in the circle here. So let me show you. This first small slice of pie, or this small slice of pizza, is a 30-degree angle. And if you look around the circle, there are other small slices of pizza here, right? Here I've got a small slice. Here I've got a small slice. And here I've got a small slice. And they're all related to one another because they are all 30 degrees off of the x-axis, right? I mean, if you take a look, from the x-axis, you either go up 30 degrees or down 30 degrees to get to these angles. Up 30 or down 30. And so that distance we travel from the x-axis we refer to as the reference angle. That's what relates all these angles here that I've drawn. They have the same reference angle, okay? We're going to use that reference angle to help identify what these angle measurements are. So here's how it works. So say I want to identify this angle right here, okay, the next small slice we see. You would count all the way around to your anchor point, which is the closest x-axis value, and you will then either add or subtract that reference angle depending on where you're trying to go. So here if I go all the way to 180, I've overshot my target, haven't I? I've gone too far. So I have to give back that 30-degree reference angle. And so if we were to take 180 degrees and give back the 30 degrees I overshot, I get 150 degrees. That's the angle measurement for that angle right there, 150 degrees. And in a similar fashion, I can get this angle down here. I simply go to my nearest anchor point, right, either the negative x-axis or the positive x-axis, and I will add or subtract my reference angle. So in this case, I would go to 180, and then I need to keep going to get to that yellow angle. So I'm going to add my reference angle onto that. So what I've got here is 180 plus that additional 30-degree size slice. I'm left with a total of 210 for this angle. Now this can feel weird at first, but I assure you this is the best way to learn how to navigate the unit circle. You don't want to rely on patterns or tricks. You want to know how to identify the anchor point and either add or subtract your reference angle to it. And in that way, we can quickly generate this entire wheel, both in degrees and eventually in radians. I want to give you a minute to identify this angle right here. Find your nearest anchor point, which in this case would be all the way around. It's 360 is my nearest anchor point. And then add or subtract your reference angle accordingly. What's going to get you to that yellow angle? Well, I'm hoping that you discovered that if I go all the way around to 360, I overshot my target. I would have to give back or take away that 30-degree reference angle. So 360 minus 30 degrees puts you at 330 degrees. And that is the degree measurement for this angle right here, 330 degrees. And we can use that exact same concept to generate the rest of these angles. See, this common angle here is a 45-degree angle. And if you notice, I have a few other 45-degree slices in my circle. There, there, and there. Right? All of those angles are 45 degrees off of the x-axis. They're either above or below the x-axis by 45 degrees, so they all have a 45-degree reference angle. So let's find this next slice here. Oops, let's put that back. Let's find this next slice right here. All right, so if I go all the way around to 180, I've gone too far. I need to give back my reference angle. So I'm going to subtract 45 degrees back. That's the new reference angle for these size slices. 180 minus the 45 degrees I overshot is going to give me 135 degrees. That is the angle measurement for this guy right here. And in a similar fashion, I can get this next one. I can get this angle by going to 180, and then here I need to continue going. I have to then add on more degrees. I have to add my reference angle to end up at that blue line. So that would be 180 plus a 45-degree slice. That tallies up to 225. All right. Lastly, let's get this 45-degree reference angle. Go all the way around to your nearest anchor point, which in this case, the nearest anchor point is all the way around at 360, right? Your anchor points are always either 180 or 360. But if I go to 360, I overshot. I have to bring it back. So this would be 360 minus 45. That gives me a total of 315. I hope you're feeling comfortable with this. This last angle, this last common angle here is a 60-degree size slice. We have more 60-degree size slices in our unit circle. If you notice, all of these angles are 60 degrees from the x-axis. So they have a reference angle of 60 degrees. That's why we lump them in the same group. And in a similar fashion, I can generate all these other angles just by going to the nearest anchor point and adding or subtracting the reference angle. So let's see if we can go through this one a little quicker. The nearest anchor point is 180. I overshot by 60, so I got to give back the 60-degree reference angle to get to the yellow line. 180, give back 60, puts me at 120. If I would like this angle here, I'll go to my reference point, my anchor point, which is 180. And in this case, I need to keep going. I need to add a reference angle of 60. 180 plus 60 makes this a 240. And lastly, let's get this angle. Go to the nearest anchor point, which would be all the way around the circle at 360. I overshot my target. I need to scoop back by 60 degrees. So if I go to 360 and then come back 60 degrees, that puts this right at 300 degrees. So there are all the common angles for our unit circle in degree measurement. We will do this again in radian measurement, which actually radian measurement is easier to count around the unit circle because radian measurement tells us our reference angle in the way it's written, which we'll see when we get to that discussion. We're also going to come back to this and add in our sine and cosine values eventually. So we are slowly building, again, your most powerful tool for doing trig moving forward. Keep up the good work. I hope you're doing well. Remember, you got this.